For this lesson, we're going to be talking about the remainder theorem. Enjoy! Okay, so here's the definition. The remainder theorem says that if a polynomial p of x is divided by x minus a, then the remainder is the constant p of a. Okay, so what does the definition mean? Well, there's two things we get from that. The first is that the divisor's degree and leading coefficient must both be 1. So if you see here, it says x minus a. The degree is right there, which is 1, and the leading coefficient, which is right in front, is also 1. So for this theorem to work, both of those have to be 1. The second one, says the remainder can be found by evaluating the polynomial with the 0 of the divisor. So that's what we know by p of a right here. So evaluating means substitution. So you'll see here it says p of a. That means they replace the x up here with the a value. Now notice it wasn't x minus a, it was the 0 for that. So they took the x minus a, set it equal to 0, and solved. And so they substituted a into the equation. And then they found the remainder by that method. Okay, so let's go ahead and try an example. So for this example, we have 4x cubed minus 9x squared plus 9x plus 3 divided by x minus 1. So if we're to follow the directions given to us, that means instead of doing long division, dividing by x minus 1, we're going to go ahead and divide by the 0 of that. So we're actually going to set this equal to 0 and solve. So we would add 1, and we get x equals 1. So it means we're actually going to substitute by 1, or evaluate by 1. So let's get rid of those. Okay, so I'm going to go ahead and replace all of those x's with 1. So I have 4, parentheses 1 cubed, minus 9, parentheses 1 squared, plus 9, parentheses 1, plus 3. Okay, so we'd get 1 cubed, which would be 1, so we got 4 times 1, minus 9, 1 squared would be 1, so times 1, and we got the rest. Okay, so this would give us 4 minus 9 plus 9 plus 3. Okay, so that means then the negative 9 and the plus 9 would cancel out, and we get 4 plus 3, which is 7. So the remainder theorem tells us that evaluating by 1 tells us that this 7 here is a remainder. So we could say that a remainder is 7 then. And there we go. Okay, so let's do another example. We have this polynomial being divided by x minus 2. So if we divide by x minus 2, that means we can evaluate by the 0 of x minus 2. So if we set x minus 2 equal to 0, we're going to end up with x equals 2. So we're going to go ahead and evaluate by 2, and that will give us our remainder. So let's get rid of that. Alright, so we can evaluate by 2. So that means we have 2 to the 4th minus 8 2 cubed plus 10 2 squared plus 2 times 2, and then we have that plus 4. I'll just kind of squeeze in there. Okay, so 2 to the 4th is going to be 16. We have minus 8 times 2 cubed, and 2 cubed is going to be 8, plus 10 times 2 squared, which is 4. That's going to be plus 4, and then plus 4. Okay, so we get 16 minus 64 plus 40 plus, we'll just go ahead and add that and say 8. Okay, so we have 16 minus 64, which is going to be a negative 48. And then we got plus 40 plus 8. And actually you'll see there, negative 48 plus 40 plus 8, that 40 and 8 add to 48, so we get negative 48 plus 48. So that actually that whole thing cancels there, and that means our remainder then is going to be 0. And that is actually really important, and we'll talk about that in a second. Okay, so what can we learn from this? Well, there's two division problems we just did. The first one gave us a remainder of 7. The second one gave us a remainder of 0. What's more important to us is the remainder of 0. That means when we divided this polynomial by the x minus 2, that means the x minus 2 divided perfectly, evenly right into it. That's like saying 12 divided by 4 goes in there 3 times, which means we have a remainder of 0. That means 4 is a factor of 12. Or in our case, that x minus 2 is a factor of that polynomial. So the long story short, a remainder of 0 means the divisor is a factor. So I could ask you, is x minus 2 a factor of x to the fourth minus 8x cubed plus 10x squared plus 2x plus 4? Is it a factor? Your answer would be yes. For the first one, is x minus 1 a factor of that polynomial? Your answer would be no. And those would be questions that could be asked. Thank you very much for watching. I hope you enjoyed the lesson, and have a great day.